Good day to you all. This is C.S. Srinivasarao, lecturer in SVK and Dr. K.S. Raju Arts and Science College, Penugonda. Welcome back to BFS algorithm. BFS means breadth first search algorithm. Here we are using the data structure is called Q. Q data structure is implemented in BFS. Right? What is the BFS? BFS means breadth first search algorithm. This algorithm executes BFS on a graph beginning with graph G, beginning with a starting vertex A. This is the same graph. This is used. The same graph. Adjacency list is here. For A, adjacent vertices are B, C, D. B, C, D. For B, only adjacent vertex is A. For C, the adjacent vertices are A and K. For D, adjacent is A, K, L. And for J, adjacent vertex is L, M. For K, adjacent vertex for K, adjacent is C, D, L. For L, the adjacent vertex is D, J, and K. Order D, J, K. And for M, only adjacent vertex is J. Right? So this is the adjacency list. This is the graph. This is the adjacency list. The same graph is implemented in DFS by using the stack. Now I want to explain the BFS algorithm by using the Q data structure. This is the Q data structure is here, right? First, what are the steps in BFS algorithm? Step 1, initialize all vertices to the ready state. So each and every vertex status is ready status. So the status is equal to 1. There are 3 statuses for each and every vertex. Initially, each and every vertex status is 1 means ready state. And status is equal to 2 means waiting state. Waiting in a particular data structure. If this is a queue, so that waiting in queue. And status is equal to 3 means that is the processed. The vertex is already processed. The status is 3. These are the 3 statuses. Status 1 means ready. Status 2 means waiting. Status 3 means process. Now initialize the each and every vertex with the status is 1. Status is 1. Right? Now initialize all vertices to the ready state. The status for each and every vertex is 1. And put the starting vertex A, this is the starting vertex A, into the queue. This is the data structure we are implementing is queue. Implement, what is the queue operation? First in, first out. First in, first out. So you can place the new item, add the new item into the queue by using a rare pointer. And you can remove the items from the queue by using friend. From friend, you can remove from by using rare you can place, add the items into the queue with the help of rare, remove the items from the queue with the help of friend. Right? Friend and rare are the 2 pointers we are using in queue. So first in, first out, that is the policy for queue. First in, first out. The which element comes into the comes first into the queue, you can remove that first element from the queue. That is the order, right? That is the queue data structure. Put the starting vertex A in queue. Whereas in stack, for example, the stack is implemented in DFS. The process is last in, first out. So the stack is last in, first out, right? The queue is first in, first out. Put the starting vertex A in queue and change the status A to the waiting state. First you visit this one. Just you take the A and change the status from status 1 to status 2. That is the status 2 means waiting state. Right? And repeat steps 4 and 5 until the queue is empty. In the queue, only one element, that is A. In the queue, the element is only one element, that is A. Right? So repeat the step 4 and step 5 until the queue is empty. Remove the first. What is step 4? Remove the front vertex. This is the queue. For example, this is the queue. The pointer, front pointer here, rear pointer here. Suppose if you want to add items, now add it to here. If you want to remove these items, remove the first from this. So remove B, add a new element X into the queue, addition to this D after D. Right? This is the queue operations. Right? Coming to the step 4. Remove the front vertex A, that is the queue, from process N. At present this one. Only one element in the queue starting. So remove this one from the queue and status is 3, that means process. A is process. you visited A, right? A is process. And after that, step 5, examine each neighbor of A. What are the neighbors of A? B, C, D. B, C, D. First you place B, then C, and then D. So first you place B, next you place C according to order, and lastly you place D by using rare pointer. So now the friend of the queue is B. Friend of the queue is B. Right? Once each examiner examine each neighbor, one is the B, C, D, and the status of the first B. What is the status of B? Is 1, and change the particular, add the B to Q and status value, add into the Q, and status of this one is, status of B value is 2. Initially B, C, D, all the status values are 1, right? And what is the next neighbor of A? C. So again C, verify the C status, initially that is 1, and add C to Q, here Q, and status of that one is add a particular C to the Q by using the rare pointer, and reset the status of that one. Status of this one is also 2. And what is the next neighbor for A? Is D. D is the next neighbor, third neighbor. So again the third neighbor is status is 1. This status is 1. So and make it add to the Q, add it to the Q, and make the status value, change the status value to 2. So status of B, C, D values are 2. Status is 2, waiting state. And in the queue, the front element is B, next element is C, third element is, last element is D. Now once the step is over, end of step 3 loop, and go for this. Again, end of this one, and verify it. The queue is not empty. So a queue has B, C, D, and remove the front vertex. What is the front vertex here? Which vertex is in front? So B is the front vertex in the queue, right? So remove that one and process it. Make that particular B status is 3. That means you process it. You already processed A. Now you process B from A to B. This is the visited. After A, you visited B, right? Visited B. And once the status is processed, this one process, examine each neighbor J of N. What are the neighbors of J? One is neighbors of B. Neighbors of B is only one vertex, that is called A. So verify that. Neighbor A, neighbor for B is A. So what is the status of A? Status of A is process. That is already So status of A is processed, already processed. Now the second condition for the step 5 is, if it is ready state, just place into the queue and reset, change the status of that one is 2. If it is neighbor is status is either the waiting or the processed state, simply ignore it. So for the neighbor of B is A, this is already processed, simply you ignore it. Simply you ignore this particular A, right? So B is process. Once the end of this one, just you remove the next element from the queue. Now the front of the queue is C. You remove that C. Only DC are there. Front of that one is C. So you remove that C and verify it. So what is the status of that one? Remove that one value, C, this one, and change the status is 3 and process it. C is processed. Once A, then B, after that C. C is a process, right? Once C is processed, and examine the neighbors of C. What are the neighbors of C? One is the A and second one is K. So one is the A. A neighbor is A. Neighbor for C is A. What is the A status? A status is 3. That is already processed. Simply ignore it. And what is the next neighbor for C? Next neighbor for C is K. So next neighbor for C is K. The K status is 1. Just add the K to Q and change the status value is 2, waiting state, right? So add K to status. Before D, after D, K is there. After D, K is there. Only one element K. So after D, K is there. Now you get the D. now in Q only two elements, one is K and second one is D. K is here, K and D. So just you remove the D, and once you remove the D, so verify it, what is the status of that one, change the status, the D is processed. Once you reach D, D is processed, and find out the neighbors for D. Neighbors for D is K and second one is L. K and L. Neighbors for this one is AKL. A is already over, KL. So once you place K and then L. K is already visited, that is in Q, and the newly element is L. So K, L, the both status are changed to 2 waiting state. And in Q only two elements, one is K and second one is L. You remove that K and process it. So once you process the K and verify the neighbors, one is D, already processed, one is C, so that is already processed, only L. So L value is just L is in a Q, right? Once the K is processed, then only element in Q is L. So you get the L value, L from this one, and you process that L value and verify the neighbors of L. Neighbors of L is J. So J will be placed in a Q by using the rear pointer, and once you place the J into the Q, so J value is, the J status is 2 and only element in the Q is J. So then you get the J and verify the neighbors of that one. Neighbors of that value is M. So that M vertex status is 1. You change the M status to 2, and J is processed. Only element in the Q is M. So once the status of that M is 2, so you remove from the Q and process it. Once that is processed, the Q is empty. So terminate the total algorithm. So here the visiting is from A to B, B to C, and after that you visited C and then visited D. From D to, after D you visited K, after K you visited L, after L you visited, after L you visited J, after J you visited M. So this is the BFS algorithm. Breadth first search algorithm. We are using Q data structure in this. So this is called BFS algorithm. Now I will explain the remaining topics, directed graph and all topological order in the next video. Thank you one and all.